All right, let's review Kepler's laws. So Kepler's first law states that planets move in elliptical orbits about the sun with the sun at one focus. And we can actually draw that like this. So what we can do is, and I'll actually do this here, I'm going to go ahead and just grab a little ellipse shape here, drag it, make it a little bit bigger. And the point of this little picture is that if we draw one point here, and we have, this is the focus of this ellipse. If we take another point right here, there would be the sun, and a planet would actually just kind of be right here, going on this circular orbit about the sun. Now, Kepler's, sorry, this is supposed to say second law, little typo. So Kepler's second law of planetary motion says this. Planets sweep out equal areas in equal times. And there's a couple of implications here, which I will include. So we'll just say this. So planets equal areas in equal times. And there's a couple points that we need to make here. So first, let's just put a little planet here and just say that over the course of 1 month, when it's closer to the sun, this, it's going to sweep out this short, fat area. And then when it's further out here, it's going to sweep out this long, narrow area. And just to be clear, it moves slower here, the further away from the sun it is, and faster here, the closer to the sun it is. And these are actually equal times, so this would be like 1 month. And this would be 1 month. That's the idea. Okay, so, all right, so. Now, next problem, Saturn has an orbital distance that averages about 9.6 AU. We want its orbital period in years. So just to be clear, this is the formula t squared, so t1 squared. Let's try this again. So we have t1 squared over r1 cubed equals t2 squared over r2 cubed. So we'll call planet 1 Earth, so this is R1, and this is T1. So we have 1 squared over 1 cubed equals T2 squared over 9.6 cubed. We'll multiply both sides by 9.6 cubed, like this. And that cancels. So we end up getting t squared, t2 squared, Saturn's period squared. And this answer is going to be in years when we're done. When we actually work this out, we're going to end up getting a period of 29.74 years. So 29.7 years. All right. Now, I kind of did this one wrong. I said Uranus completes an orbit every 84 years. What is its orbital period? That's going to be, well, that was silly. 84 years. Sorry about that. Do me a favor, though. See if you can prove that the orbital distance, I believe you should get around 30 astronomical units for the distance. See if you can prove that. And then kind of show that to me. So this is where F period ends the test, and G period has a couple more pages to do on the exam.